1942. American factories are running 24 hours a day, 7 days a week, building tanks for North Africa, bombers for Europe, warships for the Pacific. Everything the military needs to win World War II. Except there's a problem. A problem nobody's talking about publicly because if the Germans found out, they'd know just how vulnerable we really were. American transmissions were failing. Catastrophically. Gearboxes in our tanks lasting maybe 100 hours before complete failure. Differentials in military jeeps grinding themselves to pieces. Aircraft systems stripping gears under combat loads. And when Army engineers tore apart those failed transmissions, they found the same thing every time. The gears were garbage. Not a little bit imprecise. Fundamentally, embarrassingly bad. Teeth cut at wrong angles. Inconsistent spacing. Surface finishes so rough you could see tool marks with your naked eye. We were losing the manufacturing war before our soldiers even got to the battlefield. German gears in captured vehicles, lasting 1,000 hours or more under the same conditions. Swiss precision gears, 1,200 hours. American gears, 100 hours if you were lucky. We were making gears 10 times worse than what the enemy was using. And here's the truly humiliating part. The United States government, the country that invented mass production, that put the world on assembly lines, was buying precision gears from Switzerland, a neutral country, during a world war, because American manufacturers simply could not make them accurate enough. We'd pay 10 times the normal price, wait 6 months for delivery, ship them across submarine-infested waters, all because we didn't know how to make a gear that wouldn't destroy itself. Every tank needed 200 gears minimum. Every bomber needed 500. Every warship needed thousands. And we were importing them from Europe while fighting a war in Europe. But in spring of 1942, a 34-year-old mechanical engineer from Michigan walked into a government procurement office with a promise that sounded insane. He could make precision gears better than the Swiss. Faster. Cheaper. Everyone thought he was delusional. What happened over the next 90 days would change American manufacturing forever. This is the story of how America went from buying gears from Europe to dominating the precision gear industry worldwide. How one company started in a basement with $5,000 borrowed dollars and ended up in every race car, every performance transmission, every application where failure wasn't an option. But to understand why American gears were so bad, you need to know what happened in 1920 that destroyed our precision manufacturing before it ever started. The problem. 1913. Henry Ford perfected the moving assembly line. Moving production. Interchangeable parts. Specialized workers doing one task repeatedly. And most importantly, speed and volume over precision. Ford didn't need perfect parts. He needed enough parts. Build them fast. Build them cheap. If something broke, replace it. Parts were disposable. Precision was expensive. That philosophy spread through American manufacturing like wildfire. By the 1920s, every factory was chasing volume over precision. American manufacturers could hold tolerances to about 1/16 of an inch. Sometimes 1/32 if you were careful. That was considered good enough for automotive work. Good enough for farm equipment. Meanwhile in Europe, Swiss watchmakers were working to tolerances of 1/1000 of an inch. German engineering firms were building machines with exacting specifications. Generations of apprenticeship training producing master craftsmen. Two completely different philosophies. And for peacetime manufacturing, the American way seemed smarter. Why spend years training craftsmen when you could hire workers off the street? But gears are different. A gear converts rotational force from one shaft to another. Changes speed. Changes direction. Transfers power. And for that to work smoothly, the teeth have to mesh perfectly. We're talking precision measured in 10,000ths of an inch. Tolerances that seemed absurd by American standards. If teeth are cut at wrong angles, you get vibration and noise. If spacing is inconsistent, some teeth carry more load and fail first. If surface finish is too rough, friction creates heat that breaks down lubrication. If heat treatment is uneven, the gear warps and never runs true. By 1940, the average American gear lasted maybe 50,000 miles. A Swiss gear in the same application, 200,000 miles. We were making gears 4 times worse than Europe. Then Pearl Harbor happened. America entered World War II. And precision suddenly mattered. Sherman tank transmissions failing after 60 hours in North Africa. Jeep differentials grinding to dust. Aircraft gears stripping under load. The Army tested a captured German vehicle. Transmission gears lasted 900 hours. American equivalent, 80 hours. The government's solution? Import them. In 1942 alone, the United States spent $18 million importing precision gears. About $400 million in today's money. It was humiliating, expensive, strategically dangerous. And one engineer was about to change everything. The man, Elmer Borg. Born 1908, Michigan. Son of a machinist. Grew up around machine tools, learning to cut metal and understand tolerances. Got a mechanical engineering degree from University of Michigan in 1930. Right in the Depression. Spent the 30s working at Detroit automotive suppliers. He developed a reputation, brilliant engineer, obsessively precise, but difficult to work with because he refused to accept good enough. He'd argue with supervisors about tolerances. The drawing says plus or minus 5 thousandths. Borg would insist on 1 thousandth. His co-workers thought he was wasting time on details that didn't matter. But Borg had a theory. Precision wasn't just about meeting specifications. It was about fundamental strength and durability. A precisely made part would last 10 times longer than an imprecise part, even if both met minimum requirements. Nobody agreed with him. So in 1940, he quit and started consulting from his basement. Taking small projects. Making precision parts for clients who needed better than mass production could deliver. He wasn't getting rich. But he was proving his theory. Parts he made lasted longer. Performed better. Word spread that if you needed something made right, you called Elmer Borg. Spring 1942. Borg hears the government is desperately seeking domestic precision gears. He makes an appointment with an Army procurement officer in Detroit. His pitch, I can make gears as precise as the Swiss. Better, actually. Faster and cheaper than importing. I can start in 90 days. The officer looks at his credentials. One-man operation. Basement workshop. No factory. No employees. Mr. Borg, every major manufacturer in America has tried. Ford couldn't do it. GM couldn't do it. What makes you think you can? Because they're all using the same methods. Methods that don't work. I'm going to use completely different methods. The Army's desperate. They offer a challenge. 90 days. Make 100 gears to military specifications. Tolerances of 1/10,000th of an inch. Surface finish specs Swiss manufacturers barely meet. Load capacity exceeding civilian use. Success. Production contract. Failure. Bankruptcy. Borg takes the deal without hesitation. Everyone expects to never hear from him again. Just another optimistic engineer who doesn't understand how hard precision really is. But Borg wasn't planning to use traditional methods. He was going to completely rethink gear manufacturing from first principles. And what he came up with was so radically different that when Swiss engineers eventually learned about it, they couldn't believe it worked. The innovation. Here's how everyone else made gears in 1942. Start with soft steel. Cut the teeth using a hobbing machine. Hand file to adjust spacing. Heat treat to harden. Hope it doesn't warp. Hand lap to fix the warping. Measure the final result. This had fundamental problems. Heat treatment warped gears unpredictably. The same process would produce different warping every time. Hand lapping depended entirely on craftsman skill. And you only measured after everything was done, too late to fix errors. Elmer Borg looked at this process and saw it completely backwards. First insight, heat treat before cutting, not after. Everyone said you can't cut hardened steel. It'll destroy your tools. Borg's answer, use harder tools. He experimented with carbide tooling, brand new technology that could cut hardened steel. If you heat treat first, the gear can't warp during heat treatment because it's already done. Revolutionary. And nobody had thought of it because everyone assumed cutting hardened steel was impractical. Second insight: calculate ideal tooth profile mathematically instead of copying existing designs. Traditional gear makers copied what worked. Borg used involute curve mathematics to design the theoretical optimal tooth shape from engineering principles. Third insight: measure during cutting, not after. He built custom gauges that measured in real time. If something was off by 1/10,000th of an inch, adjust immediately. Traditional: cut everything, remove from machine, measure, discover it's wrong, scrap it. Borg's method: cut, measure, adjust, continue. Finish with correct dimensions guaranteed. Fourth insight: control environmental temperature. Metal expands and contracts with temperature. If you're holding 10,000th tolerances and temperature varies 20 degrees, your measurements are meaningless. Borg built a temperature-controlled room. Constant 68 degrees. Cut all gears there. Measured them there. Eliminated thermal expansion as a variable. He wasn't improving the existing process. He was replacing it entirely. The 90-day countdown began. Days 1 through 30. Built custom carbide cutting tools and temperature-controlled room. Days 30 through 60. Developed measurement system with custom gauges calibrated to millionths of an inch. Days 60 through 85. Cut the 100 test gears. Each measured dozens of times during cutting. Each cut from pre-hardened steel. Each finished without any hand-lapping. Days 85 through 90. Final inspection and documentation. Day 90. Borg loaded 100 gears into his car. Drove to the Army testing facility. Delivered them personally. And what happened next shocked everyone. Army testing was rigorous. Built around Swiss standards. First test: dimensional accuracy. Every tooth on every gear measured. Specification: 2/10,000ths tolerance. Borg's gears: 8/100,000ths. 2.5 times better than required. More precise than Swiss imports. The techs thought their equipment was broken. Ran measurements again. Same results. Second test: surface finish. Microscopic analysis of tooth surfaces. Specification: 16 microinches roughness. Borg's gears: 8 microinches. Twice as smooth. The inspectors asked what polishing he'd used. He hadn't used any. That was straight from the cutting tool. Third test: load capacity. Stress each gear to failure. Specification: 5,000 pounds minimum. Borg's gears: 7,200 pounds average. 44% stronger. Fourth test: endurance. Run continuously under full military load until failure. Specification: 100 hours minimum. Borg's gears: first failure at 347 hours. Average over 400 hours. 3.5 times the requirement. The Army engineers couldn't believe it. Results so far beyond expectations they suspected fraud. But it was real. Elmer Borg, working alone in a basement with borrowed money, had made gears superior to Swiss precision gears. Not equal to. Superior. Within a week, government contract for 10,000 gears, funding for a factory, priority materials access. The challenge now was scaling up. Making 100 perfect gears with personal supervision was one thing. Making 10,000 with trained workers was different. But Borg understood that precision isn't about skill, it's about process. Design the process correctly, and you can achieve consistent results at any scale. He hired 12 workers. Didn't want experienced gear cutters with bad habits. Hired mechanically inclined people and trained them his way from scratch. Built 6 temperature-controlled cutting rooms, each a copy of his basement setup. Created detailed process documentation. Every step written down. Every parameter specified. Nothing left to worker judgment. Every gear measured by 2 inspectors independently. If measurements didn't agree, the gear was flagged. 6 months later, first production batch delivered. Same precision as the original 100. The process worked at scale. By 1944, Borg gears were in every American Jeep, half the Sherman tanks, multiple aircraft applications. Failure rates dropped to nearly zero. Transmission lifespan tripled. Then 1945. War ends. All military contracts cancelled. Everyone assumed Borg's company would disappear. But he asked a different question. Who else needs precision gears? August 1945. War ends. Within 60 days, every contract cancelled. Factory built for 100,000 gears a year. Suddenly, 0 orders. Borg was weeks from bankruptcy. A hot rodder from Southern California showed up with a broken rear-end gear. I go through these every 3 months. Can you make something stronger? Borg examined it. Classic mass-production gear. Imprecise tooth cutting. Poor surface finish. Inconsistent heat treatment. I can make you a gear that'll last 10 times longer. How much? $150. Stock costs $20. You want $150. Stock lasts 3 months. Mine lasts 3 years. Which is cheaper? The hot rodder did the math. Ordered it. 3 months later, he was back, not because it failed, but ordering more for friends. The Borg gears had actually improved his car's performance. Smoother, faster, more reliable. Word spread through the Southern California hot rod community. 1946 to 1947. Borg started getting visits from racing mechanics. Early drag racers. Hot rodders. All with the same problem. Gears failing under modified engine power. Borg saw the opportunity. Racing valued performance over cost. Understood reliability. Needed what he could make. 1947. Borg launched a performance gear division. Marketing to racing shops. Your gears fail because they're not precise. Precision equals strength. Pay more once or pay less repeatedly. Racing culture was skeptical. All about cheap speed. Junkyard parts. Spending $150 on gears seemed excessive. So Borg did demonstrations. 2 gear sets. Standard racing gear versus Borg precision gear. Both tested to failure on a dyno. Standard gear failed at 3,200 pound-feet. Borg gear survived 5,800 pound-feet. 81% stronger. Racers paid attention. Reliability is speed. A gear that doesn't fail is a race you don't lose. 1948. NASCAR officially forms. Transmissions breaking constantly. Smokey Yunick, legendary NASCAR mechanic, orders Borg gears. Wins 3 races in a row. 0 failures. Other teams notice. By 1950, a quarter of NASCAR ran Borg gears. Early NHRA drag racing discovered Borg. Instantaneous shock loads were shattering standard gears. Borg gears survived. 1956. Ford developing high-performance Thunderbird. Stock gears failing in testing. Partnership deal. Borg supplies gears for performance Fords. 1957. The BorgWarner T10 4-speed transmission. First production car transmission with Borg precision gears. Became legendary in the muscle car era. Corvettes. Mustangs. Camaros. By 1960, $5 million in revenue. 200 employees. NASCAR, NHRA, Ford, Chevrolet, Chrysler all customers. Borg had proven precision wasn't just for military. It was competitive advantage anywhere performance mattered. But in 1961, Top Fuel Racing was about to push his technology to the limit. Early 1960s Top Fuel. 1,500 horsepower engines. Transmissions exploding. Gears shattering. Even Borg's precision gears were failing. The problem wasn't precision anymore. His process produced gears accurate to millionths of an inch. But precision didn't matter if the material couldn't handle top fuel forces. The problem was material strength. The steel was reaching its limits. Borg partnered with metallurgy labs. Experimented with different steel alloys. Different heat treatments. Different surface hardening. Traditional gear steel was 8,620 alloy. Good for most applications. But Borg needed stronger. He developed custom 9,310 steel. Higher nickel. Higher chromium. Better toughness. Superior fatigue resistance. Then specialized heat treatment. Carboizing, infusing carbon into the surface. Created case-hardened surface, extremely hard exterior, tough interior core. 1963. Borg Super Duty gears. 9,310 steel. Case hardened to 60 Rockwell. Designed for 2,000 plus horsepower. Results were immediate. Gears lasting entire seasons instead of 3 races. By 1965, 90% of Top Fuel ran Borg. NASCAR presented different challenges. 500 miles at sustained high RPM. Heat buildup. Constant stress. Borg experimented with cryogenic treatment. Freezing gears to minus 300 degrees. Rearranged metal grain structure. Reduced friction. Less heat. Gears that showed wear after 3 races now lasted entire seasons. 1965 Daytona 500. 15 cars with Borg gears. 13 finished with 0 failures. Non-Borg cars, 60% failure rate. By season's end, 85% of NASCAR ran Borg. NHRA Pro Stock in 1970, 100% Borg from day one. Offshore powerboat racing discovered Borg. Same problems, massive horsepower, shock loads, harsh environments. Borg solved them. By 1975, 78% market share across all motorsports. 15 million revenue. 500 employees. 47 patents. Borg had dominated an entire industry. But the company's name was about to change. 1970. Borg Warner Corporation makes an acquisition offer. Elmer Borg is 62. He agrees on one condition: stays as technical director. Here's the irony. The company started because America couldn't make precision gears. By 1970, Borg Warner was exporting gears to Switzerland. To Germany. The students became the teachers. Elmer Borg retired from active work in 1978 at 70. Held 83 patents over his career. NASA consulted with him for lunar rover gears. They worked perfectly. Never failed during Apollo missions. 1982. Automotive Hall of Fame induction. He died in 1994 at 86. Borg Warner today, $14 billion company. Supplies gears for Formula One, NASCAR, IndyCar. Every modern dual-clutch transmission uses technology Borg pioneered. Headquarters still in Michigan. Still the reputation Borg built. If it cannot fail, use Borg Warner. But the impact goes beyond one company. The techniques Borg developed spread through American industry. CNC machining. Aerospace manufacturing. Medical devices. Anywhere precision matters, you'll find what Borg pioneered. He funded technical schools, created apprenticeship programs, trained generations of machinists who spread his methods across industries. By the 1980s, American precision manufacturing equaled or exceeded European standards. Because Borg proved you could combine American volume with European precision if you designed the process correctly. Today, when people talk about American manufacturing quality, they're talking about capabilities that didn't exist before Elmer Borg. When a transmission lasts 200,000 miles instead of 50,000, that's precision gear manufacturing, which Borg proved was possible in America. There's one more lesson that explains why this story matters today. 1942. America had a manufacturing problem. We could make quantity but not precision. We were importing gears during a world war. 2026. American precision manufacturing, CNC machining, aerospace components, medical devices, all built on foundations Borg helped create. Because Borg proved something fundamental. Precision isn't about slow, handcrafted work by master artisans with decades of training. Precision is about process, about understanding physics, about controlling variables, about measuring during production instead of after, about designing methods based on engineering principles instead of tradition. And once you understand that, precision can scale, can be taught, can be replicated. That was Borg's real innovation. Not just better gears. A better process for making gears. One that worked in a basement and worked in a factory. Don't accept impossible. Question it. Challenge assumptions. Everyone said you can't cut hardened steel. Borg asked, what if we use harder tools? Everyone said precision requires handcraft skill. Borg asked, what if we engineer automatic precision? Everyone said copy successful designs. Borg asked, what if we calculate from first principles? One person, one basement, one impossible problem, and determination to solve it differently. The modern transmission in your car uses principles Borg developed. The racing transmission in a top fuel dragster uses gear technology he pioneered. The NASCAR differential uses manufacturing techniques he invented. Every time a transmission doesn't fail, that's precision. Every time gears last 200,000 miles, that's engineering. Every time American manufacturing exceeds world standards, that's the legacy of engineers like Elmer Borg. Because in 1942, we were buying gears from Switzerland during a war. By 1970, Switzerland was buying from us. One engineer refused to accept that American manufacturing couldn't compete. He didn't just compete. He revolutionized the industry. America didn't know how to make precision gears. We were 4 times worse than Europe. Our gears failed after 100 hours while Swiss gears lasted 1,000. And one mechanical engineer with 5,000 borrowed dollars said, I can fix this. He reinvented the entire manufacturing process, challenged every assumption, achieved precision nobody thought possible. From basement to multi-billion-dollar corporation, from American weakness to American strength. Started 1942. One man, basement workshop. First contract, 90 days, 100 gears. World War II, over 500,000 military gears. 0 combat failures. By 1975, 78% market share. Today, Borg Warner, $14 billion in revenue. Global leader. Patents, 83 held by Elmer Borg personally. Legacy, every precise gear in American manufacturing traces back to what Borg pioneered. Every racing transmission. Every performance differential. Every application where failure isn't an option. America didn't know how to make precision gears. Until one company, one man, proved American manufacturing could exceed European precision. Not by copying their 200-year-old methods, but by thinking completely differently. By engineering from first principles. By refusing to accept impossible. If you want more stories about American innovations that changed entire industries, about engineers who refused to accept limits, about companies that transformed manufacturing forever, subscribe. Because Elmer Borg wasn't the only American who looked at an impossible problem and decided to solve it anyway. He was just the one who did it with gears, and proved that American precision could compete with anyone in the world.